Okay, guys, welcome to today's ninth GCSE tutorial. My name is Michael, and I'll be helping you guys today with a GCSE tutorial. I'll tell you what we're going to be doing very shortly. We've got the very well able Stuart on the chat who's going to be helping you guys out. If you have any questions, feel free to ask Stuart. He's the guy who created ExamSolutions. So just like always, just try and get involved. Today we're going to be doing sequences, and sequences is one of those things in maths that is actually all around us. There are sequences everywhere, sequences in plant growth, population growth, genes, DNA, and therefore even sequences in behaviors. Um, People use sequences to as trading indicators to make money or lose money in the stock market. So it's really, really all around us. And just in general, the ability to recognize patterns, pattern recognition is a very, very useful skill that you can take with you, going on to your careers after your GCSE and hopefully A level careers. All right, so without further ado, today we're going to be focusing on quadratic and linear sequences mainly. I'm aware that some of us in doing OCR and AQA will be doing geometric sequences or exponential sequences, but we're going to be focusing on the linear and quadratic today. If you guys have any questions, let me know. We've got quite a few slides to get through, so let's just go ahead and get straight into it. Okay, so a sequence. So the definition of a sequence is it's a list of ordered terms which follow a certain pattern. So guys, let's have you guys answer this. What type of sequence is this? Does anyone know? Just to inform you guys, there's always a little bit of a lag, so it's going to take a little bit, a few seconds to get to me. But let's see who's first in. We got Sam first in with arithmetic. Anyone else? Arithmetic, linear. Okay, fair enough. Good. Anybody else? Okay, I can confirm that this indeed is an arithmetic sequence. So I've seen a couple of interesting phrases: arithmetic, linear, arithmetic AP. I'm assuming stands for arithmetic progressions. That's all correct. Okay. Now the reason it's called an arithmetic sequence is because the difference between consecutive terms is constant. Okay. Another word for that difference is called the common difference, plus 2, plus 2, plus 2, as you see here. And that's why it's called a linear sequence, because as you can see, the terms are increasing in a linear fashion. Okay, so well done, guys. Let us have a look at the next one. Whoops, let's go. What type of sequence is this? Who can spot it? Who's quickest to spot the pattern? As I said, it's always a great skill to be able to spot patterns very, very quickly. Who's got this? Anyone? Okay, so we got Sam in first. Looks like Sam not competing, but Sam's taking the lead today already. She says Fibonacci. Add last two numbers together. Kaz, I'm seeing that you're seeing it as well. The answer is it's a Fibonacci sequence. Very, very good. In fact, this is the original Fibonacci sequences, and you know it's a Fibonacci sequence because each term is a sum of the two previous terms before it. Okay, so for example, let's 2 is equal to 1 plus 1, 3 is equal to 2 plus 1, 5 is equal to 3 plus 2, and so on and so forth. And you can use that same pattern to get subsequent terms. Okay. All right. Next. Good work, guys. We're doing well so far. What type of sequence is this guy? Who's first in to spot the sequence? You're not required to be able to see it straight away, okay? Of course, the most important thing is accuracy and not speed. Um, so, try a few things out. I just naturally try. I naturally try the difference between the terms first. If that doesn't work, then I see maybe if something else could work. Anybody know what type of sequence this is? Okay, I'm going to tell you that this is a quadratic sequence. Okay, now the reason why it's a quadratic sequence is because when we take the first difference, we see that the terms of the first difference aren't constant. It's not as before. Okay, but when we take the second difference, we can see that the terms are constant. Okay, so that is what a typical quadratic sequence looks like. All right, and we're going to be looking at how to solve problems with quadratic sequences later on. Okay, next on. Who's got this one? What type of sequence is this? So those of us who might be doing A level or might be doing AQA or OCR, it's important that you know these types of sequences. Okay, Sam says geometric. Mohammed, geometric as well. Anybody else? Yep, GP from Max, good. GP from Din, good to have you guys coming in through. And I can confirm that the answer is it's a geometric sequence or geometric progression. Now, how you know it's a geometric progression is we can get from one term to the next by multiplying by what's called a constant multiple. And this constant multiple is called the common ratio, okay? And the common ratio here is 2. Okay, so 2 times 2 is equal to 4, 4 times 2 is equal to 8, and so on. All right, last one. Let's have a go at this one. Who's quickest to tell me what type of sequence this is? Who's got it? Who's quickest? This one should be easy. Remember, there is a bit of a lag, so it's going to take a few more seconds to get to me. For those of you who are joining, we're just learning how to recognize sequences. So Max comes in with AP. Anyone else? Marcus comes in with AP. Anyone else? Din comes in with AP. Looks like we've all got a ceremonious answer. Anybody else? Anyone have any different answers? All right, okay. Okay, so it looks like everybody says AP. I can confirm that you guys are all incorrect. It's actually not a sequence, guys. All right. In fact, it's the number 123,456. It's just one term. Remember what the definition of a sequence is. It's a list of ordered terms. All right. You guys all did get caught out. It's a list of ordered terms. All right. A list. So what makes it a list is the pure fact separated by these commas. So attention to detail is very, very, very important. Anyways, hopefully we won't make that mistake going forward. Let's move on, okay? Now we're going to get you guys involved in finding the missing terms. So find the missing terms are the following sequences. No worries, then. Whoops. Looks like I've just knocked something up. It's so good. No worries, no worries. We all have those moments. Trust me, I have loads of those. Okay, 11 and 13, straight up. Okay, 11 and 13, good stuff. I'm going to confirm that the answer is indeed 11 and 13. Now, notice that this again is an arithmetic progression because the terms are going up in constant fashion by 2. So, therefore, we need to add 2 to get to the next term, 11, and add 2 to get to the other term, 13. Okay, let's have a go at this one. All right, good stuff. Well done, guys. Brilliant. Well done for getting involved. Fantastic. So you can even notice what type of sequence we're dealing with, and then you know its features, and then you can answer the question, or you can just try to spot the pattern. Let's try and get you guys having some answers as soon as possible. 4 and 5, good stuff. We've got quite a few stuff to get through today. All right, so we've got 4 and 5.5, so walk, slightly different. All right, the answer is 4 and 5, okay? So noticing that the difference between the first two terms is 0.5, if we were to just assume it's going to be the same, try it out, okay? So add 0.5 to the next term, that would give you 4 here, right? And if you add another 0.5, it would give you 4.5, telling you that it's a linear sequence. I'm using different words here: linear sequence, arithmetic sequence. They're the same. And the missing terms are 4 and 5. Very, very good, guys. Fantastic. Great. Who's first to get this one? All right. Who's first in for this one? Okay, Schmoky. So we got -3 and -7 from Natalie. Natalie's first in. Good to see you on again, Natalie. Good to see you on, Mohammed, as well. Kaz, all the same. Good stuff. -3, -7. Good stuff. Okay, so notice that in this case, the terms are decreasing by a constant term of 4. Okay, they're decreasing by 4. So all we need to do to get to next term is subtract 4, giving us -3, and then subtract 4 again, giving us -7. Good. Next off, we've got a few more to do. Let's go. Good stuff. Who's going? Who's going? David, good to see you on, buddy. Hi, Lily. Thanks for joining. And Junaid, good stuff. Lionel, good. Well done. Everyone was good there. Very, very good. So what's the next 2 terms of this sequence? Who's got the ability to just see a pattern and just say, boom, that's it? We've got 28 and 42. Anybody else? We've got 18 and 32 coming in from Kaz. Anybody else? I'm going to let it go to one more person. We got 18 and 32 coming in from Natalie as well. Looks like I agree with the girls there. So this is a Fibonacci sequence because in order to get a term, we need to add the 2 previous terms. So -6 plus 10 is equal to 4. 4 plus 10 is equal to 14. So therefore, in order to get the next terms, we just need to add the terms that would be the 2 terms that would be previous to it. So that would be 14 plus 4, which gives us 18, and 18 plus 14, which gives us 32. Very well done, guys. Brilliant, brilliant for recognizing. Okay, this is a Fibonacci style sequence. Okay. Okay, question 5. Let's go. Next on. Good participation, guys. Great interaction. If you guys are not seeing it, feel free to ask Stuart. He'll be more than happy to help you. Okay, so we got 27 and 81. So Hawk, 27 and 81. Great, 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 great stuff. Anybody else? I'm saying great stuff because you're participating, I'm not telling you if you're correct just yet. Good. All right. All right. All right. Fantastic. I think you are correct. This is a geometric sequence. And we can get from one term to the next by simply multiplying by a common ratio, 3. Okay, so multiplying 9 by 3, we get 27. And multiplying 27 by 3, you get 81. Okay, great stuff, guys. Let's have a go at this one. What are the next few terms of this sequence? So Norge doesn't understand. Okay, so which question precisely do you not understand, Norge? Is there a particular question, or is it? Yeah, exactly. Each term in the previous was multiplied by 3. So we've got 15 root. Wow, Natalie first in again. I think she's taking the lead once again. Okie dokie. Since Natalie's the only one in, I'm going to have to get through this quite quickly. All right, so in order to get from one term to the next, well, I can see the first term is 5, the next term is 5 root 3. So if I multiply by root 3, I get 5 root 3. And if I multiply by root 3, 5 root 3 by root 3, I get 5 times by root 3 times root 3, which is equal to 5 times by 3, which is equal to 15. So we should all know how to work with surds, guys. And I recently did a live on that, so feel free to check out the GCSE playlist on surds. Okay, so multiplying the next term by root 3, we get 15 root 3, and then multiplying this term by root 3, we get 45. Fantastic work, guys, and good stuff for coming in there, guys. Good. And the last one, what type of sequence is this? And what are the missing terms? Quadratic sequence, correct. You all have answered my question. I'd like you to find out the missing terms. It is a quadratic sequence. 27, 37, 27, 37, 27, 36. So slightly out there. Okay. All right. Is that 14 or 19, please? Oh, damn. My handwriting let me down again, didn't it? It's a 19. It's a 19. So sorry, Kaz. So sorry, Kaz. Yeah, it's a 19. Okay, so this is indeed a quadratic sequence. And we can tell because the first difference is 2, 4, and 6. And we can see there's some type of pattern in the first difference. And so when we take the second difference, we get a constant pattern, if you like, constant terms. So this is a quadratic sequence, meaning that in order to get to the next term, we need to add by 8. And to get to the next term, we need to add by 10, giving us 27 and 37. So who got that? I think David was first onto that. Fantastic. Good work, guys. Everybody smashing it. This is amazing. Okay, so we're going to move on now to finding the nth term. All right, so it's important to understand what on earth the nth term of an arithmetic sequence is, okay? Now, all it is it's a general formula which tells you the value of your of your sequence, or values of terms in a sequence at a certain position n, okay? So please note that n is always going to be a positive integer. So it's going to be a whole number. For example, this is the first position, this is the second position. The position of the value 9 is equal to 4, etc., etc. Okay, so what we're going to do is we're going to find the nth term using, I'm going to show you two methods. And first of all, it's always good to just confirm that you're dealing with an arithmetic sequence. So let's do that by simply checking that the differences are equal. And yes, they are. We have a common difference of 2. And so the first method, this is what I like to call it. I like to call it the educated guess and adjust method. Okay, so because these terms are going up in twos, we can almost make a guess that the formula for the nth term is going to be 2n. All right. So if it was 2n, this would be how it would look. It would be 2, 4, 6, 8, 10. So for different values of n, we get 2, 4, 6, 8, 10, etc. Okay. You then have to adjust this because it's not the sequence we're looking for. This is the sequence we're looking for. So you have to see how we can get there. And I can see by adding 1 to each term, I can see I'm going to get exactly what I'm looking for. All right, so 2n plus 1 is going to give me 3, plus 4 plus 1 is equal to 5, 6 plus 1 is equal to 7, etc. And so therefore, the nth term of the sequence is equal to 2n plus 1, okay? And the notation that we use in general, depending on your syllabus, is going to be u subscript n and or a subscript n, okay? So that's the notation we generally use to denote the nth term. Okay, and we can go ahead and use that notation to actually check our work, okay? So for example, we know that the first term is equal to 3, right? We know it. So we can check our work by simply plugging in n is equal to 1 into our formula, and that gives us 3, okay? So remember I said the nth term is just a formula that gives you the value at any particular position. Okay, it just spits out that value. It can tell you the value at the 100th position, for example. Okay, and that's why it's very, very useful. Okay, we can also check another term just to make sure we're right, and I advise you do this in your exams. Okay, so if we plugged in n is equal to 4, we get 2 times by 4 plus 1 is equal to 9, which we expect because we expect our fourth term to be equal to 9. All right, here's the second method, which I particularly prefer because I remember it a lot. And of course, when teaching the A-level guys, they should be very familiar with this formula, okay, which is the formula for the nth term of an arithmetic sequence, where A is the first term, D is the common difference, and N is the nth term, where again, as mentioned before, N has to be a positive integer, okay, greater than 0. All right, so looking at exactly the same sequence, we can see that the first term would be 3. The first term would be 3. And the difference, as we saw before, the common difference would be 2. So substituting this into our general formula, we get 3 plus n minus 1 times by 2. And then multiplying out, we get the final answer of 2n plus 1. So that's just another method for you guys, okay? So let's have a go, guys. Let's have a go at finding the nth term of this sequence rather. Okay, so here we have 9, 5, 1, and minus 3. I'd like you guys to try with me. I want to see who's quickest. By the way, if you guys tell me which method do you find the best, was it method 1 or method 2? Which one do you prefer to use? It's always useful to know what students prefer and why they prefer it. So if you can tell me which one you prefer and why, that'd be really, really useful. All right, so I'm just going to go through this. We're certainly not going to have enough time to go through quadratics today. That will probably be the next tutorial for Friday. So let's see who can get this before me. All right, I'm going to go ahead and answer the question. So first of all, we need to check that this is an arithmetic sequence, and it is because we've got constant terms. And using method 1, I can then kind of make a guess that the sequence is going to be minus 4n. And now I have to adjust it. I have to make this sequence equal to the original sequence. So what do I have to do to make the sequence equal? Well, I need to add 13 to all terms. So therefore, my nth term is going to be minus 4n plus 13. Okay, and using the second method, once again, we just use the same sequence. And we can see again here that a equal to 9 will be our first term, d equal to negative 4 would be our common difference, and substituting those values into the general formula, we get an answer of minus 4n plus 13. So you get exactly the same answer. That was brilliant. Good stuff. So David likes the first method best. There's probably a reason why I like the second method best, and I tend to use formulas for the quadratic sequences for finding the nth term of the quadratic sequence. So that's probably why I just like to be maybe consistent with using formulas all the way through, but it's up to you. It's totally up to you. Okay, so here's the next question I have for you guys, and it's probably one of the last because I don't think we're going to have time to go through quadratic. I don't want to go way over time. Okay, so is negative 202 a term in the above sequence? Give a reason for your answer. So Lionel likes method 2. So is minus 202 a term in the above sequence? Give a reason for your answer. So we've got an answer 13 minus 4n. Okay, I'm not sure how bad the lag is on my side. But yes, that was the nth term of the sequence we've just looked at, correct? Okay, can't really see question 2. May I zoom in? I can read it out to you. So Is negative 202 a term in the above sequence? Give a reason for your answer. And we say no. Din says no. Anybody else? David, no. Okay, what's your reason? Okay, we've got a reason from Anoop. So no, because negative 202 minus 13 is equal to, okay, minus 215 minus, okay, is not divisible. Okay, I see where you're going there, Anoop, and I think you're right. Of course, typo issues make it tough to present your answers here. N not an integer. Okay, good stuff. I'm seeing good answers here. Okay, now there's two ways you can look at it. Okay, you can look at it just by inception. Inception, is that the right word? Inspection, yes, inspection. All right. So if you look at the terms, right, you can clearly see that all our terms, well, 9, 5, 1, minus 3, they're odd, aren't they? Okay, a minus 202, it's an even number. Okay, that's an easy answer. Okay, that students often, well, might sometimes try to think too hard. Okay, so it can't be a term of the sequence. If we continue to subtract 4, you clearly see that yes, this can't be a term of the sequence. Another way to look at it, as most of you looked at it, is, well, if negative 202 is a term in the sequence, then at some point, at some positive value of n, right, positive integer, that value, that term would be equal to our nth term. Okay, so it should satisfy this equation. So going ahead to solve that, if we subtract 13 from both sides, we get minus 4n is equal to minus 215. Dividing through by negative 4 on both sides, we get 53.7. And remember what we said, n must be. It must be a positive integer. It's positive, but it's not an integer because it's not a whole number. Okay, very, very, very good. This is brilliant, guys. We're almost there. As I said, we're not going to do quadratic today because we don't have enough time. I didn't realize how many slides I had on. So what I want you guys to do is, on your own, let's see how we can get these. Okay, find the 21st term for the sequence. No worries, Lionel. Well done, guys. Well done, everybody. Good stuff. So, yeah, Kaz saw it all odd. Good. Yeah, we'll definitely make sure that we try and make the questions as big as possible for you guys to see. All right, so Natalie comes in with 47. Wow, quick answers there. Good. Marcus, 47. David, 47. Kaz has got to go. No problem. See you tomorrow, yeah? Take care and stay safe. Din, 47. Lionel, 47. Good. It looks like we're all getting the same answer. Let's have a look. All right. So again, you want to check that it's an arithmetic sequence, okay? By confirming that the first difference is constant, okay? So we do have a common difference of 2. Using method 2, where a is equal to 7 and d is equal to 2, we can get that the nth term of this sequence is 5 plus 2n. When you substitute the values, this is what you get. Okay, great. Now we've been asked to find the 21st term. Okay, so I probably should have said earlier that, the logic you would have needed to know that you need the 21st term is you first of all need to find the nth term. Remember, the nth term is just a general formula that can tell you any single value in the sequence based on your position. We're looking for the 21st position, where n is equal to 1. So our final answer would be plugging in n equal to 21 would be 47. Fantastic, guys. Good stuff. We've got a couple more questions to go and then we're done. All right. Well done. Some of us are on 100% today. Really, really good. Yeah, there is a session tomorrow. Be on A level. Marcus. Good stuff. Fantastic. So this one should be a fairly, very, very simple question, just based on what we've looked at before. How do you answer this question? If an is 2n plus 3, find an. Find a52. 107. Straight in from Max. So it's really good. We're getting so many of you guys just coming in first there, and it's good to have varying people participating. Good stuff. So Natalie, 107. Anyone else? 107 comes through from Din. Fantastic. Okay, and David as well. The answer is indeed 107. And in order to find this term, A52, we need to substitute n is equal to 52 into this formula, which would give us the answer, okay? Just remember this subscript is it's the same subscript as this one, okay? So we're plugging in n is equal to 52, and that's going to give us an answer of 107. Okay, we've just got the last question for this slide, and we'll make it the last question of the day. We'll go through quadratics next lesson. Here's the last question. All right, so hopefully you can read this. I'll read this out to you. A term in the sequence 4n minus 1 is 319. Find the position of this term in the sequence. Find the position. 80. Wow, Max in again. David, quick. Sir Hawk, slightly different there. Natalie, again, quick. Good stuff. Anyone else? 80. Din the usuals. Good, good. No worries. You times it by 2, buddy. Just always check your work. Always check your work. All right, okay. So let's have a look at this question. So we've been asked to find the position of a term which is in the sequence. We're told that this term is in the sequence, okay? Now, as you remember, I like to associate the word position to the letter n, okay? The term n, okay? So we're effectively looking for the n value which satisfies this equation, okay? Because we know that 319 is at some point, some position equal to 4n minus 1. Now we need to find out that position, n, okay? So we can simply do that by rearranging the equation and solving to get n is equal to 80, and therefore the 80th position is where the value of 319 occurs. So fantastic, guys. We're going to round it off there, and I'm just going to pop back on. Okie dokie. All right, guys. Thank you very much for joining me. You guys have been great as always. It's great to have you guys participating. I didn't have enough time to go through quadratics. I don't really want to go way over time. I've got quite a few questions for you. Keep participating, guys. Keep coming through. Tell your friends about it. We're offering these live streams here for you guys as an alternative to school and to get you guys prepared for moving on to your next years or further study or whatever. Just always contribute. Let us know which topics you demand, what topics you like us to go through, and we'll definitely go through it. I'll be back tomorrow for A levels, and yeah, see you guys. Take care. Bye bye.